Okay, so this is a video about simplifying radicals and rationalizing the denominator and literal equations. I don't think I made a video about this. I'm going to use the examples from the study guide. And so let's take a look. This is a square root right here. And so remember, for radicals, if it's a square root, we have to look at this index. And if we have two of the same, then one can come out. Okay, and so if I look at 294 and build my factor tree, and then you have a 294 divided by 2, that's going to be 147. That is definitely not divisible by 2. 1 plus 4 is 5. 5 plus 7 is 12. 12 is divisible by 3, so I know it's divisible by 3. And then we have 49, and that's 7 and 7. So inside here you have 2 times 3 times 7 to the second. And p, I'm going to break that up as even to the 6 times p to the 1. Okay, so what are the things that could come out? Anything that there is an even number for its power. So we have 1 7 coming out and p to the third coming out. And we're just dividing. Like if you understand rational exponents, we're just dividing. So those came out. So we have a 7p cubed. And what stays inside? 2 times 3 is 6. And p to the 1. Kind of draw this better. And there you go. Pretty straightforward, right? Good job. Next one. I know that this is an index of 3, and I said that most cases you'll just be responsible for square roots, but I just wanted to see. Okay, so that's 2 times the cube root of negative 104. And so if I look at 104, let's do 104 factor tree 2, and then 52. And 2, is it 20, 12, 6, and 2, 13. So we have 2 times 2 times 2, 2 to the third times 13. Let me just make sure I always multiply my factors in my factor tree to make sure. 2 to the third times 13. Now let's break the exponents of x to the 6th. You can break it up into thirds, or 6 is divisible by 3. Okay, because remember what you're going to do is just divide those. And let's break this up as y to the 6 times y to the 1. So what can come out? Let me go ahead. We need 3, that one, and that one. That comes out, 3 divided by 3 is 2 to the 1. That comes out x to the second and y to the second. And we're just taking the 6 and dividing it by 3. Taking the 6 and dividing it by 3, 3 and divided by 3, the root. Okay, whatever comes out has to multiply with whatever's outside of the radical. That's multiplying the radical. So 2 times 2 is 4. X to the second, y to the second. What stayed in is 13y. Oh, and I forgot the negative. Okay, the negative can come out. I mean, I can separate out this negative. It'll be a negative 1. Negative 1 times negative 1 times negative 1 is negative. So this is going to turn it negative. Because the negative 1 can come out. And the negative 1 will multiply with the 4. Okay? Good job. Okay, so this is a 4th root, or the index is 4. Negative 5 times, make the factor tree, 2, 32, 2, 1, 16, 2, is it 8, 2, 4, 2, 2. And if you guys already know the exponent of 2, 1, 2, 3, 4, 5, 6, it should be 2 to the 6th. Okay, 2 to the 5th is 32. So when you have 32 and you double that, or you multiply it by 2, then it's 64. Okay, and then m to the 11. We need 4. We need 4 each. Okay, so I like to break this up as 2 to the 4th times 2 to the 2nd, m to the 8th. 8 is divisible by 4, so m to the 3rd. What can come out? The 2 to the 4th and m to the 8th. 4 divided by 4 is 1. 8 divided by 4 is 2. Whatever came out has to multiply with a -5, so we get -10. M to the 2nd. What stays in to the 4th root? Did I not put a 3rd root there? Yeah. Okay, 4th root is going to be 2 to the 2nd, and it's fine if you write it this way, and m to the 3rd. Good job. Okay, next one. Remember, the radicand has to be the same in order for us to add the coefficients together. So if I look at 27, that's made up of 3 and 9, and 3 and 3. So we have 3 3's. We know one of these can come out as a 3. So that's going to multiply with a -4. There you go. And then I believe this is also a 3 and a 9 and a 3 and 3. No, that's not right. No, sorry. Let's do 5. 5 and 9, 3 and 3. 3 can come out, multiplies. 1 3 comes out, multiplies with this 6. And that's to the 5th root. The 5 that could not come out. 75, 5. 1, 25, 5. 3, 5, 5. So 5 can come out, multiplies with a -1 outside. We have a 3. Okay. Do you see any radicands that are the same? Yeah, the 3 and the 3. So you can add the coefficients. So that'll be a -17 to the square root of 3 plus 18 to the square root of 5. Good job. Next. Okay. Cube root. -2. Cube root 2. I'm going to break up that 5 and make it k to the 3rd and k to the 2nd. The cube root, take the -1, write it as separately. And then the 40, 2, 20, 2, 10, 2, 5. So that's going to be 2 to the 3rd and k to the 2nd. You can't break up the k to the 2nd into numbers that are divisible by 3. Okay, so let's see what can come out. We have a k that can come out, 1k, so it's -2k, and the cube root of 2k squared. Here, the -1 could come out because it's cube root. -1 times -1 times -1 is -1. And also the 2 can come out. So a -1 comes out and a 2 comes out. So that becomes a -2. And what has to stay in is a k squared. Now this is multiplication. We could have combined the entire thing, okay? Which would have been, I guess, easier to do, but why not have a little challenge? Okay, so whatever is outside, let's go ahead and multiply. -2 times -2 is a 4k, and I could put it inside the same radical sign because they're both 3. They're the 3 roots, or the 3rd root, and the index is 3. So it's 2 times k squared times k squared. Now I can break up that k squared as it ends up becoming k to the 4th. So k to the 3rd and k to the 1. And then, my computer's kind of laggy. And then I can have this k to the third come out. We can have one more k come out. Okay, join the k outside. So it becomes 4k to the second, the cube root of 2k. I was checking back on my work. Find the mistake. Let me know. The answer to this is not this. And if you watch the video or check the key, you should know. It's bonus points on the test. Okay, next. Oh no, I just moved something. Next. Oh no, I moved it again. Okay, next. Now we're just going to distribute this entire term. So it's going to be 5 times 10 here minus 2 to the square root of 5 times 20. You'll put it all underneath one radical sign. And so we have 2. That's 5 times 5 times 2. 2, 5 times 5 times 4. Okay, what can come out? We have a 5 that can come out, a 5, and this 2 can come out. And so we end up with a 10 to the square root of 2. And 4 times 5 is minus 40. No square root. No square root, right? Yeah, everything came out. This again, 4 times 4, 20. 20. 4 times 5 is 20. So that's negative 20 plus 10 to the square root of 2. Okay, good job. Okay, let's go ahead and expand this. 2 minus 7, square root of 2 minus 7. Okay, first, multiply the first. So 3 times 3 is 9 times square root of 2 times square root of 2 is 2. And then minus 21, the square root of 2 minus 21, square root of 2. And then plus 49. We can combine these two because the radicand is the same. And do not make the mistake of multiplying those two radicals together. You are just combining their coefficients. 42 to the square root of 2 plus 49. We can add the 18 and the 47 together. So that's going to be 17, 17, 20, 67. 67 minus 42 to the square root of 2. Okay? Well, good job. Okay, next. Okay, so remember I told you that if the index is the same, which is a 2, you can go ahead and combine it into one big radical. So 24 and 16 are both divisible by, is it by 8? Is it 8? 24 divided by 8. Yes, 8. So that is going to be 8, 2, 8, 3. So we're going to have a 3 divided by 2. And then that simplifies as 1. And then a 5, 56, square root of 56. Square root of 56. 56 is made up of, let's see, 56 is made up of 4 times the perfect square of 14. 7 and 2. So we're going to take 3/2 and multiply it by that 2 that comes out. And then the 14 has to stay inside. That simplifies. And so we get 3 to the square root of 14. There you go. Good job. Okay. Here is a problem. And there's only one of these on the review. I wish I had put more. But this is rationalizing the denominator. Remember, in order to rationalize a denominator, you cannot have any radicals in the denominator. So for example, if you had 1 over the square root of 2, then you would have to multiply by the square root of 2 in the denominator. What you do to the bottom, you can do to the top. And so you'll have these two that can come out. Okay. In this case, we have to use the conjugate. And the conjugate for this, remember I said it was like a difference of squares. So the first term is going to look exactly the same. The last term, the actual number is going to be the same, but the sign of the second term changes, is the opposite. Just like that. Okay. And then let's go ahead and multiply. We have a 10 and a minus 2 to the square root of 3 plus 5 to the square root of 3, and then a minus square root of 9, which is 3. We have 25, and then minus 5 to the square root of 3, and plus 5 to the square root of 3, and a minus square root of 3, which is a 3. We have a 10 minus 3, that's 7, plus 3 to the square root of 3. And then those middle terms cancel out. And so you end up with a 22. I think that's as far as we can simplify. Okay? Good job. Now, literal equations. Now, this is the most scientific application of algebra. Okay, being able to manipulate any kind of variable and solving for it. It says solve for Q. Okay, and in chemistry, you kind of do like those equivalent like statements. Okay, and you have the two variables on either side, and you can write it with another variable on the other side. So you can have an equivalent statement that shows the same thing, but the subject is going to change. I call it the subject because whatever comes first changes whatever it's equal to. Okay, so this is just algebra skills. And I love putting literal equations into things and seeing, because there's so many different ways. Okay, so I need to get rid of the 7. 7's in the denominator, so you really need to get rid of 1 over 7. So the reciprocal of 1 over 7 is 7 over 1. I'm going to multiply both sides by 7 over 1. So when you do that, that simplifies. And then you end up with a 5p plus q to the second. Whoops. Q to the second equals 8 times 7. 8 times 7, 56. Okay, now I'm going to isolate Q on the other side. P, Q to the second equals negative 5P plus 56. Now, in order to take the Q squared and make it just Q, you have to put a radical. You're going to square root both sides. So in squaring both sides, you have to get the plus or minus. And when we do quadratics, we'll definitely go over why it's the plus or minus. But you have to have the plus or minus on the other side. So that is your final answer. Good job, guys. Okay, let's take a look at this one. It says solve for a. Notice that there is a here in this term, a here on this term. So the first thing you need to do is collect all the a terms and put them on one side, and all the things that don't have the a's, all the terms that don't have the a's, put it on the other side. So I'm going to add 7b, add 7b on both sides, and I get 4a equals ab plus 3 plus 7b. Now I need this a, so I'm going to move this ab to the other side. So I get 4a minus ab equals 3 plus 7b. Now, we have two terms with a's in it. That means that's also a common factor. So I'm going to factor out in a. 4 minus b equals 3 plus 7b. Now, 4 minus b equals 3 plus 7b. What you did is create two factors. First factor and second factor. Now, once you do that, how do you get rid of one of the factors? Is to do the opposite of it. Okay, 4 minus b, that's in your way, so you're just going to divide both sides by that factor. 4 minus b. 4 minus b. That simplifies as a equals, let's kind of clean this up, 7b plus 3 over 4 minus b. Okay, good job. Next, solve for x. Okay, once again, we have an x here and an x here. So we had an x here and an x here. I shouldn't have put this problem on there. Now I'm regretting it without checking. Okay, the very first thing we need to do is move this to the other side. Ax squared minus x equals negative c. Okay, and then what we need to do is divide everything by a. And you're thinking to yourself, hey, I could factor out an x there, but that's not going to be enough. So what they're going to require, what this is going to require you to do, that becomes 1, is to complete the square. So you need a number here, and you need a number, the same number here. Yes, so I really regret putting this problem on here. So in order to complete the square, we have to find this special number. And the special number is found by using this 1 over a. We take 1 over a, divide it by 2, which is the same thing as multiplying it by 1/2. So 1 over 2a, and then squaring it, because it turns it into a perfect square trinomial. So 1 over 2a squared and 1 over 2a squared. Okay, and then, let's see, now you have a situation where you have a perfect square trinomial, just like this, and this equals, let's see, negative c over a, and then plus 1 over 4a squared. Okay, and then I can go ahead and combine by multiplying this by 4 and a. So I have a negative 4ac plus 1 over 4a squared. On this side, I have x minus 2a squared. And by making it a perfect square trinomial, now I can go ahead and square root both sides. When I square root both sides, I end up with x minus 1 over 2a equals plus or minus the square root of, I'm going to rewrite that without the negative sign being there, 1 minus 4ac over 4a squared. Now that denominator we can get out because 4 and a squared can come out of the radical. So x minus, and I'm going to move this to this other side. So 1 over 2a plus or minus the square root of 1 minus 4ac over 2a. We have common denominators. So it's plus or minus square root of 1 minus 4ac over 2a. There you go. I've solved it for x. What you could have also done is use the quadratic formula because it's going to solve that x for you. Okay, so you could have had a equaling a, b equaling -1, and c equaling c. And then use the quadratic formula and you would have gotten the same answer. This would be a nice little bonus problem. Okay, good job. Here, it says solve for p. Okay, let's go ahead and solve for p. So p's in the denominator, so get it out of the denominator by multiplying it by its reciprocal. So I'm going to do 1 minus p squared on both sides. So I get h times 1 minus p squared equals, and this simplifies, and we just get an r. Okay, let's see. If I distribute the h, I can, but it's already in its factored form, isn't it? So I could just divide both sides by h. So get 1 minus p squared. There we go. And equals r over h. And then I'm going to move the 1 over. Negative p squared equals r over h minus 1. And then I'm going to divide both sides by negative. So p squared equals 1 minus r over h. And then square root, both sides getting a plus or minus, for r over h. So p equals plus or minus the square root of 1 minus r over h. But we have a radical h in the denominator. I'm going to go ahead and create common denominator of h over h minus r over h plus or minus, and we're going to get in it's like h minus r over h. Now if I wanted to take that h out, then I have to multiply top and bottom by h. P equals plus or minus, and we have a square root h times h minus r all over h. Okay, for the actual test, if you get down to here, I'll give you full credit. Okay, but that little extra step to rationalize the denominator is always nice. Okay, good job. Okay, solve for r. This one's pretty straightforward. Gosh, it was not like the previous one, last, I don't know. Okay, first I'm going to multiply this by 3 because I don't like that 1/3. So I get 3v, and that simplifies as pi r squared h. I'm going to divide both sides by pi h. So I get an r squared equals 3v pi r. Now I'm going to square root both sides, plus or minus. Gosh, my computer's so hot. Oh, wait a second. That's a v and an r. Oh, gosh. Kids are not going to be able to distinguish. That's a r, and this is a v. Okay. Square roots both sides. So r equals plus or minus the square root of 3v and then pi r. If I wanted to rationalize the denominator, I would have to multiply top and bottom by pi r. So that would give me plus or minus square root of 3 pi VR over pi. Wait a second. Is that an H? Oh no, H. I'm sorry. That's an H. That was 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 an H. And that's an H. Okay. That could be the final answer. This could be the final answer. Okay? Good job, guys. Let's see, T. Okay, this is kind of similar. I'm going to multiply both sides by 2. That'll get rid of that 1/2. 2s equals gt squared. Divide both sides by g. So t squared equals 2sg. Square root both sides. Taking the plus or minus. G plus or minus the square root of 2s over g. To get that g out, multiply top and bottom by g. Okay, so t equals plus or minus square root of 2gs over g. Or, since this is our first test, if you give me 2s over g all inside the radical, I will still take it. Okay? Good job, guys. Last two. Solve for y. Oh, this is the same one. Oh. This time I'm going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so we have a 1 equaling a. We have a 2 that equals b. And this entire thing is going to be c. So negative c equals c. Okay, so x equals negative 2 plus or minus 2 squared is 4 minus 4 times 1 times negative c all over 2a, or 2 times 1. X equals negative 2 plus or minus, and we have a 4 plus 4c all over 2. Okay, now look what I can do. I can take out a 4 here. 1 plus c over 2. My computer's very slow. It's very hot right now. And how does that help me? Well, if I multiply those two things inside the radical, that means I could also take it out and make it individually radical. Just like that. So, x equals negative 2 plus or minus 2 to the square root of 1 plus c over 2. And that means that I can simplify a 2 in every single term. Whoa. I don't know. Maybe I have too many applications open. I don't think so. 2 browsers open. Okay. So every single term, you see a term here, a term here, and a term here. So x equals negative 1 plus or minus the square root of 1 plus c. That's your final answer, or you can complete the square. I'm actually going to pause the video and check it by completing the square. I did it as the blue. Completed the square, I got the same thing. Okay, last problem on the study guide. Solve for k. Okay, so first I'm going to get rid of this denominator by multiplying by its reciprocal, which is 1 minus ab over 1. 1 minus ab over 1. That'll get rid of the denominator. And do not get that confused with a conjugate. Okay, because you don't need to find the conjugate here. That was an expression. This is an equation. Okay. So j times 1 minus ab. And we're not multiplying by 1. When you did the conjugate, we multiplied by a 1. And for expressions, we have to multiply by 1. For equations, whatever you do to one side, you have to do the other side. Okay, and you get k squared. And then you just square root the k squared plus or minus j 1 minus ab. So you get k equals plus or minus the square root of j times 1 minus ab. And you can leave all of that inside. And there you go. We're done. I think so. I've done all of them, right? Come on, zoom out. Come on, zoom out. Yep. Good job, guys.